Let's draw the force diagram for the book. So this is the book, and the forces acting on it are mg, force of gravity, acting straight down, which is what is trying to slide the book down along the wall. The next force is the force with which the person is pressing the book against the wall. Let's call that force F. And since the book presses the wall pushes back with the force which we call normal reaction. And since the book is trying to slide down, the force of friction acts upwards, and let's call it F. Now this is the force of static friction when the book is not sliding. Since there is no acceleration in the horizontal direction, we have F is equal to N. So the harder the person presses the book, the larger is the normal reaction with which the wall presses the book back. When the normal reaction increases, mu s times n increases. What is mu s times n? Mu s times n is the maximum possible value of static friction for a given value of n. So in other words, friction can be any value less than or equal to mu s times n. So friction will adjust itself to whatever value is needed up to mu s times n. Let us start with applying a very small force. So F is small, N is small, mu s times n is small, and therefore the friction, the static friction, is going to be also small, not large enough to keep the book from sliding down. So if I press gently against the book slides down. Let's increase the force with which we push the book. Increase F, normal reaction N increases, mu s times n increases. When mu s times n becomes larger than mg, then the static friction can adjust itself to mg to keep it from sliding. So the minimum force we need to apply, which is equal to the minimum n, is given by mu s times n equal to mg. Let's see what happens then. Now mu s times n is also equal to mu s times F. So we are applying a force F such that mu s times F is equal to mg. So mu s times n is mg. So friction can now adjust itself up to mg. So immediately it will adjust itself to mg and prevent the book from sliding. Again, if I apply a less force than that, mu s times n will be less than mg. Friction cannot reach mg, so the book will slide down. So the minimum force required is given by mg by mu s. For example, let's say the mass of the book is 2 kilograms, and let's say the mu static friction coefficient is 0.6. In that case, the force that this person needs to exert horizontally is 20 divided by 0.6. That's about 33.3 newtons. What happens if this person applies a force much larger than that? Supposing the person applies a force which is twice this. In that case, mu s times F will become twice mg. Right? But will friction become twice mg? No. Friction needs to be mg to prevent it from sliding. Friction has to be less than or equal to 2 mg, so it will become mg, and the book will neither slide up nor down.